Hi everyone, I'm Antonio Lima. Welcome back to this fourth lesson of ProSAP. In today's lesson, we are going to talk about BIM. Hello everyone, I'm Antonio Lima from USA, and in today's lesson, we're going to talk about the BIM usage and the import-export from ProSAP using an IFC file. For this video, I'm gonna help myself with a couple of slides in order to introduce the argument and to better explain you how all of this works, because it is not a really simple object, and I think this is quite better. So let's start with this. First of all, we'll talk about what it is an IFC file, and basically it is a file, an open source file that every software can read. So it is independent from the software that generated it and that is gonna use it. An IFC file basically just contains informations about objects and entities inside the structure and so the file. Usually in this schema, because it's called IFC schema, there are a lot of entities. Each one of these represents just only one element of our structure. First of all, we have to talk about the main differences between a BIM model and a FEM model, because they are very different from themselves, and they are based on different kind of representations and philosophy, just say like this, especially for what concern the modelation and the representation of the objects. What characterizes a BIM model? It is a large amount of information that are, let's say, categorized by a lot, as I said, level of detail. So the higher is the level of detail, the more are going to be the information and the details inside the IFC file. And one other very important thing is the connection of elements by volume. So in the IFC file or in the BIM model, it's not really the same, but almost. All elements are connected between with the faces of the volumes of the single elements. Instead, when we talk about FEM, so a finished element model, we notice that we have a kind of selectivity of the elements that are going to be represented, because when you model something using finite elements, you have to be selective on which elements to model and which others no. Especially you have to model only structural elements. You don't have to model everything in the structure. You don't care about architectonical elements and everything that is not structural, basically. Yes, then other elements are going to be implemented in the model as loads, but not as elements itself. And the other main difference between the BIM model and the FEM model is that on the FEM model, the connection of the elements happens by nodes. Because all the elements need to be connected by the nodes in order to transfer action from one to the other. And this is very important, and later in this presentation we're going to see in specific why I'm saying that. Let's focus on the representation type. So, In the IFC schema, there are three main types of representation of solid elements. It means that each element can be represented in different ways. There are two ways that are the more popular, that are BIREP, that stands for boundary representation, and swept solid. So, as we see in the bottom images, on the left we have our solid. Sorry, I forgot to translate, but I think it's not a problem. The original solid, that it is in this case a beam with a quadratic section. And this volume of concrete can be represented in two different ways. The first one is the extruded solid, represented as the swept solid. And that means that we have an extrusion of a section along the axis of the element. And as you will notice, this is exactly what a FEM software, a FEM model does. So it has every element has an axis and a section, and the section is extruded along this axis. So this is the easier way to describe a volume, and this also is the correct way to describe it in order to import in a FEM software like ProSAP. On the other hand, we can have the BIREP kind of representation that I tried to represent with the image on the right, in which the volume is just represented by faces that enclose the volume of the element. So in this case, the element doesn't have any kind of axis, okay? We just have some faces that describe this volume. And of course, this for a FEM model is not correct because the software, a FEM software, doesn't care much about the faces that are describing the external perimeter of the beam. A FEM model just wants that each element has an axis and a section. So the BIREP representation type is not that good for importing IFC in a FEM software, sorry, as ProSAP. I will say FEM environment. This is the correct term, but we can go. And the third option that I reported here is the clipping. So it's kind of a result of Boolean operation between solids already obtained using the previous methods. But this is just for competition. Usually it's not very much used and we don't care a lot about it. What we really care is to understand the difference between the boundary representation and the swept solid representation types. Let's have a closer look at them. The representation type BIREP, so boundary representation, as I said, uses a set of faces that enclose the volume of the element. This representation allows you to describe elements of complex geometry which must be simplified in the FEM environment. And here I reported the example of this column on the right, that is, let's say, an old style column, okay, an architectural column with a large amount of details, and that, of course, in a FEM model aren't that important. So in a FEM model, I don't care about this section variation on the height on the column, all the elements, the capitals on the top and the bottom. If I would model this in a FEM model, I will just represent it as a cylinder, so as a circular section extruded along the axis. And that is exactly what the swept solid representation type does. So this representation allows you to describe simple solid and is the most suitable for importing into the FEM environment, as the elements are already equipped with the main properties that describe a one-dimensional finite element, so a section and an axis. So this is quite simple. I mean, I think you already understand this, but I want to be very sure that this is clear to everyone. We have a BIREP representation type used especially when we talk about architectural models, and that is very detailed. And we have a swept solid that is low detailed But these minimum details are just the information that a FEM model needs. So axis and section for each element. Okay, we can go on and talk about what ProSAP does with these informations. So, first of all, we have to say that ProSAP imports and acquires IFC elements according to the instruction of Building Smart International Modeling Support Group. In the specific, here we talk about the IFC super free model, but it actually also imports IFC files of the version IFC 4, so the latest one, but it doesn't change it much basically, because the IFC 4 just had some kind of new entities that describe detailed elements, so it's something more important for architectural modelation and not for FEM. In this case, ProSAP is able to import only these elements that I'm reporting you, so building story, wall standard case, slab, IFC slab, IFC column, IFC member, IFC beam, and IFC building element that are generical elements that could be of the underwritten kind. So IFC building element proxy, IFC ramp, pile, footing plate. Each entity in the IFC schema, in the IFC file, has its name that starts with the IFC. If you don't know this, you can also open a BIM file with a text editor. Okay, I'm gonna show you this. I don't want to really focus on this. Okay, but just to try to understand what does that mean. You see, this is a file, an IFC file, in which we have a header, and then all the data in which we have a lot of entities. Each one starts with the IFC, and before there is a number that indicates its position inside the file. Most entities have several properties that are entities by themselves and are indicated by this number. Okay, this is just a curiosity to let you know, but we won't focus on this. Let's go back on our presentation. And okay, we can go. Basically, these are the kind of elements that ProSAP is able to import. If someone gives you a file that uses different kinds of entities, it is normal that the software doesn't import them, because each entity has specific rules that indicates how this entity describes the volume and the position of the element. And so, yes, these are the only ones that ProSAP is able to read. One more important thing to say is that when importing IFC models, it may happen that elements, or better to say, it usually happens that elements are not connected through nodes, even though they appear connected in solid view. So as I said before, in the architectural model, so in BIM models, the connection between elements happens by volume. But it doesn't work on a FEM, on the FEM model, because in the FEM model, each element needs to have its axis connected with a node to the axis of the other elements. Just try to think about that, because it is very important, and later we're going to see it even better. So this is an example of what the software does with the free elements, so with walls and slabs. The one on the left that you see is an element, let's say a box, described by an IFC file opened with a BIM viewer. There is this software BIM Vision that is free. You can download it and try to use it to open IFC files. And you see that when you import this file on ProSAP, moving to the second image, while using a solid view, all the elements are connected correctly to each other. But when we move to the file, to the wireframe view, that it's represented by the image on the right, all the elements are disconnected between themselves. So basically, each wall ends and it's not connected with the orthogonal wall. That's cause of this difference between the modulation and the way each file describes the volumes basically and the element itself. But there is, of course, there's a way to correct this, and we're going to see it. Same for column BIM and member. So for each linear element, you see on the left the structure on BIM Vision imported in ProSAP with the solid view. It seems fine because all elements are connected. But when we go wireframe view on the right, we can easily see that the elements are not connected between each others. Another quick thing to say is that on the IFC schema there is the possibility to import also materials. The only property that materials can have and that of course can be reported to ProSAP is basically its name. So in the architectural domain of IFC, the only property of IFC material is the name. So basically here, what does ProSAP does? I'm sorry for my English sometimes, I think it's not the best. Basically, ProSAP automatically recognizes materials according to the two keywords. So if the name of the material contains CLS, that basically is just an abbreviation for calcestruzzo in Italian, calcestruzzo or concrete, then it automatically assigns a generic concrete type material to the element. So basically it takes the first concrete material on the archive and assigns to the element. Instead, when it reads acciaio or steel, it assigns a steel material type, same for muratura and masonry with the measuring material type, and legno, wood or timber for a timber material type. If none of these keywords are found by ProSAP or are not used in the IFC file, a generic material type is assigned. Why I'm saying this? Because okay, you are structural engineer, so you're probably gonna just use IFC files that are gonna come from architects or other colleagues. And but when you create, if it ever happens to you, an IFC file, you're supposed to create it in a logic way in which you assign correct names to the materials. In the example that I reported on the right, the architect called the material grigio verde. That is a color, and of course this helps the architect in moving between the model using some sort of order that it is only in his mind. So it's not generic, it is not global. It doesn't mean the same thing for everyone who opens the file. So it is better to use correct names for each material and not color names or improper names like this example. But let's go on. When you try to import an IFC file on ProSAP, you first of all you're gonna find this window. In this window, ProSAP is gonna basically tell you on the left how many elements, how many entities are present in the IFC file for each category. So you can see that, for example, in this file that it was importing, there were 20 slabs, 20 slabs with walls, 57 walls, 13 beams, 18 columns, and stop. And for each of these element types, you can choose which kind of import to use. Okay, basically you always have to check element D2 when it's possible for column, beam, and member. Instead, for wall and slab, you can either choose mesh T3, so it automatically imports a mesh, or it's better to import as construction lines, so it's just like to import a DXF basically, but later with a command you can transform these lines in a mesh T3. This is quite helpful when it comes to corrected geometry, because you first correct the geometry of the D2 elements and then you generate the mesh of the wall. Another important thing about this window is that you are not forced to import everything in the same moment. So basically you can first import the linear elements, so the two elements, correct them, move them, do all your things, and then in a second moment, using a second import command, you're gonna import walls and slabs just to complete the structure. And sometimes this is better than do everything on one shot. Because especially with big files with complicated structures, this can be quite a pain to correct the geometry. Why am I saying correct the geometry? Because as I already said, as I showed you, when you import the file, you want to obtain a model ready for the analysis, because all the elements will be separated by the others and not connected with nodes. Except, of course, if you import an IFC file generated by another FEM software. Because if you import a file generated by another FEM software, the other FEM software follows basically the same principles as ProSAP, and so they talk the same language and they represent the elements in the same way. So the file is perfectly importable in ProSAP. But in most of the cases, you're going to import files generated by architects in architectural environments like Revit, just to see one. And so you have to correct the geometry. For doing this, in order to do this, ProSAP has a command called help for BIM that allows you to correct the geometry by stretching the elements with a certain radius of action until nodes are connected to each other. In this screen that I reported, basically you can see where the command is placed inside the ribbon bar, and on the right you see these red circles that appears around each node that stands for the area of effect of the command, and that shows you which nodes are gonna basically matched by each other. Okay, what does this command do? As I already said, I'm just reading now, is performed by stretching structural elements and not adding rigid arms. Why I'm saying this? Because other softwares, like Revit itself, usually generates some rigid arms that connects the nodes that are not really connected. But this generates some kind of problems, because the file is gonna become a lot heavier, and you're gonna have sudden change in stiffness between the elements that makes the resistance hierarchy more difficult to automate. So yes, this is what is reported in this slide. Once the geometry has been adjusted, you can use the mesh command, which generates the mesh of walls and shells with the correct geometry. So as I said before, if you import walls and shells as construction lines, the command mesh of this window automatically transforms them in a D3 mesh, so in a mesh of finite elements ready for the analysis. This is an example, the example that we're gonna see right now in ProSAP. of a structure in the moment that it is imported on the left. So you see that this is a simple structure, of course, in which you have all the beams that are not connected with other beams and with columns. Floors are not even in the same plane of the beams and even beams are not in the same plane of the others. It depends on their section. And well, after the use of L4 beam on the right, you have your basically your finite structure that is ready for the analysis. You just have to assign external boundary to apply loads, and then you're ready to go. Okay, this was everything for the quick presentation. Now we can move to ProSAP and have an example of how does this works. So to import the file from here, we can go up on the left here on BIM and import IFC. You can just select an IFC file. In this case, for example, we're going to use a file of the super free schema exported by the plan. And here, as I showed you, you have on the left the amount of elements of each kind that are present in the IFC file, and on the right the options of import. These are the default options that I suggest you not to change. So basically, beam, column, and member elements, so linear elements, are by default imported as the dual elements, and instead slab and wall elements are imported as construction lines. Only slab polygonal elements can be imported as floor items. This is not possible for slab elements with holes. It's missing a word here, because basically ProSAP does not support floors with holes. So you can just import them as construction lines, and then it stands to the ProSAP user, to model it manually using the floors or the free elements, so which elements you prefer. Okay, basically you can go import IFC, you receive this message, reading IFC was successful. Ecco, there we go, okay. This is a file that basically I show you also in the presentation. And of course, we see that we are not able to run analysis from there. If we go check structure data, yes, of course, I have to save it. So import sample. Hello. Okay, don't mind this warning. Of course, as I was saying, if we try to do the check on what we just imported, the software is going to tell us that if we have potential ability and we need more checks. Yes. This is because elements are not connected by the others. We have no external boundaries. So basically, this structure is floating. Basically, this is not even a structure. It's just some elements put in here. What we have to do to use the command edit L4 beam. So we see that this window shows up, in which are reported every kind of correction that the software can apply to which kind of elements. In particular, we can apply correction for dimension. Dimensions stand for quotes, so all the elements that are not placed on the same quote will be moved in the z-axis, with the columns, all the columns will be connected to the upper or the lower one. First of all, I suggest you to move this radius for the range of action to the maximum, so from 20 to 40. That is the maximum. And basically, when you move to an element, you can see like a segmented line that shows us basically the results of the application of the command. Then you can do that for walls, for beams, for floors, etc., etc. The automatic basically corrects automatically everything. It applies all the correction in the same moment, but I suggest you not do that because usually it gives bad results. It is really better to use them one by one in the order they are suggested by the software. So forget about automatic. You can see just from the preview that some elements are no more linear. There's something really bad in this command. So just focus on doing this one by one. First of all, we can go dimension. Another thing that I can suggest you is to cut out the allow division for columns. Otherwise, they'll be divided into some little pieces. I mean, instead of stretching the elements, we just generate a new element with the same section and material of the columns. It is not a rigid link, but it will split the column in some cases. In some cases, it's fine. In some cases, maybe not. So let's do the dimensions first. With fix, you apply the command. Okay. And now we see that basically everything for each floor is now in the same quote. This node is out of quote, but it is not a problem. We're gonna correct it later. Let's correct it right now. So basically these are two different elements, I think, yes. So it is better to cancel this one. I'm gonna hide the floors. This is not an element, this is just a line, a DXF line. So we're gonna stretch. Let's click here. Move to stretch node from here to here. Okay. Now we're fine. We can go back to the for BIM. We just did. Okay. Let's show again the floors. Edit for BIM. With dimensions, basically columns are being automatically fixed. In fact, we have no more connections no more geometry to correct. With wall, you see that before this command, the wall is not connected. Okay, this is a beam, but the walls have the problem that I was saying you about during the presentation. So they are not connected. With wall, I can go fix, and now you see that I are correctly connected in the edge. With the mesh command, the software automatically generates also the D3 element mesh that is representing our walls. Then we can fix beams, and last the floor, and let's go. Okay, now we see that basically each element seems correctly connected. We have some pieces, let's say like that, of elements that are outside the structure and that we can cut out. And in order to do this, we can move to the data view box. Let's do this and cancel. Okay. Okay, now I just forgot one. Now our structure seems fine and ready for, okay, here we can see another little imperfection. As before, we can use the stretch node command. From here to here, okay, perfect. Perfect. We can use the split up view just to check that everything is fine. It seems so. And okay, what do we need now? Just to apply the external boundaries on the nodes. To apply set reference. We can move to the X plus view and with box select all the nodes. Right click assign reference. And basically from here it's done. We can go the check structure data. Find overlapped nodes, okay. automatically remove. Okay, basically, usually using this command, some nodes can regenerate or can be overlapped. It's not a problem. That's the check structure data that solves this for us. You can just say no. So correction, repeat check. Okay, here we add a node out of everything. If I click cancel node, that probably belongs to the floor. Check structure data, and now it's done. Okay, so we can move to load assignment. I'm gonna do it the fast way. Yes, yes, good. Okay, now we go. This is also a fast recap of the previous lessons. Go in here, place Ferrara. Apply. Okay, let's go on. Let's create combinations. General settings. Okay. A combination, basically combination. Okay, now we can run the analysis. Okay, we have some kind of warning, but okay, right now we don't care about that. We just did this for the purpose of show you how to import the file. I'm not gonna fix every problem of the structure, and the important thing is that right now basically we run the analysis and we can check actions for our structure. And we see that we are fine. So starting from an IFC file using the add command, we correct the geometry of our structure and we run the analysis in order to obtain the classical results. As you see, this is not automatic at all, because you have to use this command, let's say, using your mind, so reasoning about what is going to happen, the right order to use the correction geometry for an element instead of another, and so it's just not a magic that you have one click and the structure is complete. But for sure is a command that really helps you on passing from an IFC file that gives you a structure not ready for analysis to pass to a structure well done, well connected, in which every element is well connected to the other, in order to obtain the results of the analysis. So basically, this is all for the usage of the IFC file and using of the BIM methods using ProSAP.